Assalamu alaikum. I am Abdul Muqeet and today I am here with another lecture of DSP, that is systems. In first lecture we consider I told you about the basics of DSP. In second lecture I told you about the signals, and in third lecture I am going to tell you about the systems. What are systems? What are its types? And what are the properties of the system? So system process signal to create other signal. System is a device that would process a certain signal to get a certain another signal. And here we can represent any arbitrary signal via scale data or shifted data. Then we have the systems. The cascaded system. There are basically three types of systems: cascaded systems, parallel systems, and feedback systems. In cascaded systems, when we have two systems in series, then we can say that that system is a cascaded system. And if we have two systems in parallel, then we can say it's a parallel system. And the third type is a feedback system. In this type of system, we use the a part of output as an input to get the desired output. Then we have the properties of system. Following are the properties of system. As you can see that I have written causal systems. So what are causal systems? Well, causal systems are those in which we consider present and past. As you can, this is the example that let's suppose we have y of n is equals to x of n minus 2, x of n minus 1. X of n is the present state of the signal, and 2x n minus 1 is the past of the signal. Basically that's and so and vice versa, we can say it is a non-causal system, in which we are this is the example of the non-causal system. Then let's talk about the linear systems. What are linear systems? A system is said to be linear if that system is first additive and then homogeneous, if it holds the properties of additivity and homogeneity. So what are additivity and homogeneity? Let's discuss there. Additivity is when you have let's suppose a system over here where it's an input signal, it's a system, and the output signal. And then we have the second system, that is x2 of n goes through the system, and y2 of n. Then if we add if we add both inputs, so the resultant would be the addition of the both outputs. So that's the property of the additive systems. And let's talk about the homogeneous systems. Let's suppose we have a system over here, x of n, system y of n. Then if we multiply the input with a factor, let's suppose beta, then the output should also be the same factor divided by the output of the system. So such kind of systems are called what? Homogeneous systems. Then we have the superposition theorem. What is the superposition theorem? If a system first of all, what superposition theorem has to do with this, with the system? If a system follows superposition theorem, then it is a linear system. And what is the superposition theorem? When we combine these two properties, here you can say x1 of n plus x2 of n, which is the additive property, and certain factor is being multiplied with both the inputs, and that is the homogeneous property. Then then it passes through a system. Then the output should be the same factors multiplying with the sum. So that's the superposition theorem. Let's take an example that will help you with this. Suppose we are given an output y of n is equal to x of n minus 2 x of n minus 1, and we want to check whether it's linear or not, whether the system is linear or not. So when a system is linear? A system is linear when it holds the superposition theorem. And what is a superposition theorem? It is when a system is additive plus the homogeneous system. So first we're going to check the additivity of this system. Let's say that x1 of here you can let's say that x1 of n is the first signal, and this will implies that x1 of n, this actually this is the input signal and the system is this. Since the system will convert the input signal into this, and it will give the output. So x1 of n here is x1 of n minus 2 x1 of n minus 1 is equal to y1 of n. Okay, and let's suppose we have the second signal x2 of n. Similarly, it will go through this system and it will become x2 of n minus 2 x2 of n minus 1, which is the second output, sorry. So this is the additive property. X1 of n plus x2 of n should give y1 of n plus y2 of n. Let's suppose there's another signal z of n. If we and z, let's suppose z of n is another signal. We are supposing it over here is equals to x1 of n plus x2 of n. So if z of n will pass through this system will convert this input into z of n minus 2 z of n minus 1 when it passes through the system. So but here z of n we have considered it at x1 of n plus x2 of n. So we can write this system as this x1 of n. When this signal is passed through this system, then we'll get the output x1 of n plus x2 of n minus 2 x1 of n minus 1 plus x2 of n minus 1, basically the sum of the outputs. Hence it is additive. As you can see that it is the sum of actually the inputs x1 of n x2 of n summed with minus 2x1 x of n minus 1 and minus 2 x2 and minus 1. When you take the minus 2 common, then we are left with this. So hence the additive property is. Then we take the homogeneity. What is homogeneity? When you multiply a input signal with a certain factor, then its output should be also the should be multiplied with the same factor. Here let's suppose we have n. So let's suppose we have a z of n is equals to alpha x of n. Here and we know that z of n when passed through that system is z of n minus 2 z of n minus 1. So when alpha is multiplied, then we have uh, uh, alpha x of n minus 2 alpha x of n minus 1 x of n minus 1. So if you take alpha common, then it is alpha, and this is x of y of n. So here you can see that we have alpha y of n, so it also holds the homogeneous property, hence the given system is linear. Let's consider another example. Y of n is equals to x of n plus 5. We're going to go through the same procedure as we have gone through the first example. We're going to take x1 of n, which will be x1 of n plus 5 will be the system, x2 of n plus 5, and when we add both inputs, then the output should also be added. But here you can see when we add the both inputs, we have the answer x1 of n plus x2 of n plus 5, which is not equal to y1 of n plus y2 of n, which is not equal to, hence it is not non-additive. And similarly for the homogeneous, z of n is equal to alpha x of n. When z of n is multiplied with, we have alpha x of n plus 5, which is also non-homogeneous. So this was the basic lecture of systems and their properties, and how we can prove whether the system is linear or not. Thank you.